This thing disappear.
It should be okay.
I think it is.
Hi, I'm Pauline Luc, and this is Semantic Segmentation using adversarial networks. And this is joint work with Camille Couprie and Soumith Chintala from Facebook AI Research and Jakob Verbeek from INRIA. So, state-of-the-art semantic segmentation is a computer vision problem where the aim is for each pixel to predict which category the pixel belongs to. And state-of-the-art methods typically rely on a convolutional neural networks and often employ a CRF model to model a structure in the output space. And those CRF models can, for instance, involve fully connected graphs with a certain parameterization for the pairwise potentials, or instead have a very rich parameterization for the pairwise potentials in locally connected CRFs, or integrate higher order potentials in the model. But all of these approaches must make a compromise between the connectivity of the graph and the expressivity of the parameterization of the potentials to allow for tractable inference. And so in this work, we aim to learn the structure based on adversarial training rather than modeling it. So we train two competing models against each other, just like in the GAN setting. The first model is our segmenter, so it's going to perform the task at hand. And we train it using a hybrid loss, of which the first term is the conventional multi-class cross-entropy loss used in semantic segmentation. The second model is an adversary network for the segmenter, and it's going to we're going to train it to distinguish between the segmentations output by the segmenter from those that come from the ground truth. And so this is the global min-max objective that both networks play. And in turn, the segmenter is going to be trained to as well fool the adversarial network. And so in the different views that were discussed previously, you can really see this as using the discriminator here to try to learn a loss rather than specifying it. So we explore different encoding schemes for the inputs fed to the adversarial network. In the first one, the basic one, we directly provide the probability maps, but of course there's a risk that the adversarial network will trivially distinguish between both types of inputs because the ground truth consists in one-hot vectors. So the first strategy that we propose to avoid this problem is to, or at least mitigate this problem, is to segment the input image with each of the probability maps by element-wise multiplication with each of the RGB channels. The second strategy is to produce noisy segmentation maps from the ground truth by setting for each spatial location the distribution such that there is a high enough probability on the correct label, on the ground truth label, and the rest of the, and setting the other class probabilities such that the distribution looks as much as possible to the distribution that was produced by the segmenter. So in terms of qualitative results on Stanford background dataset, we observe significant gains across all three commonly used metrics. And we also observe that, as you can see on the curves here, adversarial training significantly reduces overfitting. And on PASCAL we observe smaller but consistent improvements on the validation and test sets. And qualitatively, the adversarial training smoothens and strengthens the predictions across large areas. And as you can see here in the pictures, also so removes some of the spurious predictions in small areas. This is another example, and for more details, and in particular about the training procedures that we tried out, come and see us at the poster. Thank you.
So in this work, you are generating a discrete object, right? So that, do you think this will have, you could transfer these kind of methods to generate language or others?
So one thing, so the first, in these different methods that we tried, we found by pre-training the adversarial that the discriminator did not have 100% accuracy. So the fact that, at least the first seems trivial, and it probably leads the adversarial to focus maybe on things that are not of interest to us. But maybe it's also equally trivial to, make sure that large areas, that pixels close by have the same label. And I'm not sure if there's something like that in, and this is obviously something that interests us and that we want the model to learn. So maybe there are easier things that are, that the model is able to learn in semantic segmentation, and I'm not sure that this is true for language.
Thank you.